emailed you. Yes, are you this person? You need to come see me at the end of class because there's something bad about you on Canvas. Did you not get my email? I emailed you last Wednesday. You what? You didn't get my, I emailed you. Yes, yes. All right, get your piece of paper out. Listen, everybody. Do not write the word Tony on your quiz page, because I have 200 of you potentially, and I have another class. So I need you to print your first name and last name very clearly. If I have to go and I can't figure out what the hell you wrote down, and I have to go look at your RUID, I'm going to subtract 10 points. This quiz is only worth 8. You do the math, right? All right? So I want everybody's answer to be one sentence long. Do not write a novel, all right? I don't want a novel, all right? Because then I have to read all of you, and then I'm going to stop doing quizzes, all right? All right, so write down your first name and last name. Everybody do it. Every Wednesday, get ready to do your RUID, do your signature. All right, listen to me. Just look up here for a second. Give me one situation or scenario where the mutation that affects the normal feeding behavior of C. elegans is beneficial. I'm not telling you what the mutation is, because if you're in class, you know what it is. So give me one reason or scenario where that mutation is beneficial, all right? For number 2, you're going to write a little table or whatever where you're going to write down cost, benefit. So, what from the flat wing low cricket point of view, okay, what is the cost and benefit if there are no or very, very few normal singing males? One sentence. Do not just write down no benefit. Give me at least a reason why. No, because. Yes, because. None, because. All right? Hurry up. Go. I'm going to set my alarm for 30 seconds. As soon as you're done, put it up here. One sentence. Think about it. If you have a question, put up your hand now. If you didn't, yes.
I just joined the course.
Kiss my ass. No. Don't worry. Give me your name. When did you join the course?
Like a few days ago.
Come up here. Give me your name. You know what's more important? You get the notes. This is a worthless 8 points, all right? But you can also kiss my ass, too. You know, this is why I hate ad drop, honestly. Oh, yes. Are you Kim?
No.
Good God, people. I was hoping everybody would drop. Who's willing to drop this class? For everybody who missed last week's class, it was a double period. So you need to get the notes. These points. These points are tiny compared to missing the note. All right? These points are nothing. Because on average, I ask 17 questions or more per lecture. So 17 times 2 is way more than 8 points, all right? So get the notes. What happens if you miss lecture? One less person to face. Any more questions? Who's going to drop the class? Please. Well, because I don't want them to walk in front of me.
Okay.
You know, if you cheat, I always catch cheaters. Not all, but cheating is not worth it. If you let somebody caught copy from yours, you're also cheating. So not only the person that's asking. Box. Always the box. I just don't want these people walking in front of me. Oh, two personality, huh? No, who cares about that? Trust me, we're all Scantron exams, you can get all you need. Oh, you want me to do the work? You can get my email from last week. Yes, so in Canvas, you are at the bottom of the alphabet. You're not on the P, so that screws me up. I'm gonna have to drop it from the class because I can't keep moving. When I put the grades in by the roster, the roster will tell you. In Canvas, you're Zio, Patel, Zio, and they said they only the student. So people can change it. You can put pictures on there. If there's a picture on there, that means you can edit it. You have to put your last name first, because otherwise it's spoil thing, because you're almost in the middle of the alphabet. I keep having to move you down and shift everybody to grades who are below you. Like, so, oh, you can tell me,
8:30.
Is it wise to come in at 8:45? 9:35? No. All right, people. Someone put up your hand. Now, everybody who answered last week, put up your hand. Don't put up your hand, all right? Let somebody else have a chance. I will desperately go to the people who know everything afterwards, all right? So what is one possible situation where, first of all, someone put up their hand and tell me, what is the mutation? What is the normal feeding behavior and what's the mutation? Did you answer before, last week? Okay, you don't remember last week? What's the answer?
Normally they're in clusters.
Yes.
Groups, and the mutation is
Okay, somebody tell me what is one possible scenario that is beneficial? Did you answer last week? Okay,
Maybe where like the food source of bacteria spread out to the source.
yes, so the bacteria is spread out. What's another possible answer?
There could be less competition for food.
Could be, but don't forget it's a mutation, all right? But it could be, yes. What's another possible way? Another thing.
Could help find more nutritious.
More nutritious, or the fact that, so it could be that there is very little food. So if you are behaviorally adapted to clustering, it is not beneficial, right? Now, I want you guys to remember, this is a course about evolution and behavior. If a particular mutation exists enough that they can find it, there has to be some, what's the word I'm going to say next? It has to be a benefit, right? There are nobody here who has no heart, or except for me, I have no heart, right? Because you can't possibly live with no heart. So if there's a mutation that is so detrimental to the individual, you would very, very rarely find it. You would never find enough of them because it is so bad that it doesn't live or something and then it dies. That's gone, right? It's not a beneficial thing. They don't have time to pass it on and mate and everything, right? So you understand. Because sometimes what we're going to do is we're going to go through all kinds of examples where, again, the cost benefit is not 100 to 0. It's 59 to 51 to 49. There's just a little bit. So if you can have enough reproductive success, even a small amount that you can pass on, will your behavior exist? Yes. All right. All right. So the flat-winged males, can they sing? Is it a good mutation on that Hawaii island? It is only a good mutation under what condition? Someone put their hand.
It prevents the parasitic.
No, give me the one condition that the flat-winged male mutation is beneficial.
It's not that it avoids being attacked by the parasitoid.
Yes, exactly. That's the answer. So the answer is the only benefit for to have a flat-winged mutation and have it spread is it doesn't get infected by the yellow parasitoid fly, right? Because the yellow parasitoid fly has to find insects to lay its larvae and egg and all that kind of stuff. And the easiest thing for all these parasitoid fly is to hear an insect, because they're all small. So it may not be cricket, it may be some other animal, but they gotta hear it, right? If you are sitting in the jungle, in the pitch dark, and there's silence, but then you hear a voice going like, Bob, 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 you're gonna go, oh my God, somebody's here, it's gonna save me. That's who you go to, right? So that's the only time the parasitoid flat-winged male is beneficial, because it doesn't make any noise, so it will not attract the yellow parasitoid fly, all right? So now, if there are very, 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 very few singing males left, what is the cost to the flat-wing? Someone tell me someone give me a possible answer. Yes? Yeah. And right, so that's a big cost. So if they are like that, what does the flat wing do? What is one change in their behavior? They got to move around a little more. So is there any benefit to the flat wing? Is it a lot of benefit? Yes, they do survive, but is it a really big benefit though? I mean, yes, it's a benefit because you don't get infected, right? But the benefit is not huge because you now need to find female another way, right? Right? So again, it's not 100% zero because now everybody's silent, right? So there has to be enough success for the flat wing because otherwise we would never find flat wings. And it's not increasing. So again, the whole thing about all this evolution is that again with the optimum trade value and all that kind of stuff is you don't have to have 100 to 0. You could just be a little bit better than other individuals, right? Yes? All right. Does anybody have any question about this? All right. So today we're going to talk about the concept of proximate and ultimate behavioral causes. You know, I forgot last week, I got on a roll and I didn't have a break. Were you guys okay with it? Yes? I don't want to see a single person say, hey, can you get us a break? If you do, I will hunt down your IP address and do something to you. All right? All right, so we're going to talk about these two in a broad context of behavior. We're really into behavior, but keep in mind, everything we talk about is about evolution, all right? So the original people, this was not called behavior. The original science was called ethology. It's the study of behavior in wild animals to make a distinction as opposed to lab animal, domesticated animal, the stupid dog in your house, all right? My dog is not stupid. In nature, so under natural conditions, by observation and experimentation. So the original ethologists were Europeans. So way back in the 40s and 50s, all the European people were out there observing birds and fish and lizards and rodents and saying, what are they doing? So their first thing is they're out there looking, and then they're saying, why is that animal doing this, all right? Then they would do little experiments out in the wild, and then depending on the animal species, they took it into the lab to make a control situation. So there's same amount of sunlight, same number of human interaction to see if it really is the kind of conclusion that you have out in the wild. The Americans decided to work on mice and rats, you know, the Skinners and everything. So it was all these rats going, cocaine. And they say, ooh, apparently the subject likes cocaine and keeps tapping the lever. Well, duh. Or sugar, or whatever, or LSD, or whatever they were giving them. But it took a long time for the Americans to get out of the lab box with the rodents and start looking at animals outside, right? So what I do is I like studies where it combines outside observation and then you bring it in the lab to control to make sure that your conclusion outside is confirmed by a conclusion in the lab, all right? Now, who are the famous 3 European ethologists? I'm sure you guys, if you've taken any psych classes, you know their names. Anybody know their names? Anybody? I think this is on the MCAT. So who are the 3 famous European ethologists? But nobody knows? Yes? Sigmund Freud. What an idiot. No, he did not work on humans. He worked on poor, stupid humans. Huh? Okay, no more answers. I'm done. You guys, darn with it. He did, but he was not born in the 1950s. All right. I thought for sure you guys have no. Okay. Does that name sound familiar to anybody? You will. None of you will be doctors. Thank goodness. Anybody have any recognition? Anybody better? Anybody recognize anything? No. They are the only behavioral ethologists that have won a Nobel Prize in medicine. The only people, right? Because medicine is all about solve cancer, right? So they won the Nobel Prize in 1973 for behavior. Everything you know about behavior and the words I'm going to use, you're going to go, oh shit. That's because they invented those words, they attach it to behavior, and it's the behavior that you guys think about when we talk about behavior. Nobody before had thought about them, but they did. And all the Americans are trying to catch up to them, all right? So they did their research way back in the 50s, and they got their Nobel Prize in 1973. Now, Tim Bergen is very, 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 very famous. He died before I knew about that. But he came up with 4 questions. He said that if you are doing any kind of behavior study, you have to at least attack some of the 4 questions. You can't always attack all 4, all right? These are the 4 questions about behavior research. One, what is the mechanism that causes the behavior? All right, so this is the thing, like if let me think about this. Ah! You see, what happened? How many of you looked up, right? So this is a very, very specific, what was the mechanism that raised your heartbeat and caused you to look up? Me screaming, all right? So one of the questions is, what exactly causes the behavior, right? So if you have those great tick birds, right? What causes the behavior? An object, a novel object placed in their environment next to food, right? That is the food and a novel object. So it causes them to go, right? Those are the actual causes. So you're looking at the actual mechanism. Is it auditory? Is it visual? How does the behavior develop during the lifetime of the individual? I hate development. I find it so boring. If you develop normally, you develop normally. If you develop abnormally, you develop, I don't really care. So we're not going to do anything about a lifetime of an individual, all right? 3, what is the function of the behavior? Or essentially, why is the animal performing it? And the 4th question is, how did the behavior evolve? So these are the 4 questions. He said that if you're going to you're going to do a study on behavior, you should attack one of them, 2 or 3 or 4. But these are the questions you have to ask when the thing. Why is C. elegans doing this behavior? Why is C. elegans not doing this behavior? Does C. elegans change its behavior as it's growing, right? Is there any benefit to C. elegans having that mutant behavior where it disperses when it comes to feeding time as opposed to not, all right? Now, what do you notice about these 4 is that questions 1 and 2 are asking proximate causation. They're actually saying what causes and what changes as you are growing up. So we're not going to go do any development, but I'm just going to give you an example. Some bird species, when they hatch, will sing the song of that species perfectly, all right? We're going to talk about that. These are called innate behaviors, right? They will sing it just perfectly, and the mother and the father go, oh, my offspring, right? Some species do not, all right? They have to learn the song of their parents and their kin in that population, right? And then over time, with those species, you can go and manipulate them. You can play, you can capture them as eggs, take them into a lab, and play a different song from their species. And say, oh gosh, they learned it. So they have a suite of genes that allow them to learn their song. Now, if you take these individuals that learn a different song and you put them back with all their other kin, everybody's going like, what the frig is he saying? What's he saying? Let's all avoid him, right? Because that's bad. You have to, when we get to sexual selection next week, you have to sing, you have to do the right thing for your species, otherwise nobody's gonna mate with you, right? So, that is, 1 and 2 is what are the direct causes. I hear a song, I'm gonna sing it. It's like if you were born on an island off in the North Pacific and everybody speaks like this, you, when you're a baby, will speak like that. You will have that accent, right? If I took you from that island and I put you to England, you'll go, hello, right? So this is all about learning. You have to have a suite of genes. So those are proximate causes. What is the direct cause? I go, and you go, okay? That is a direct proximate causation of the behavior. 3 and 4 are what you call ultimate causation. So proximate is something very direct. Right there, I go up, you go like this. I make a noise, you go like this. I bring food, and everybody goes, you know, I bring coffee, and everybody goes, oh, where's the coffee, right? Have you ever, how many people here drink coffee, right? So you go into a place and someone has brewed a cup of coffee. What do? Oh, that's the proximate cause. You've had your olfactory thing goes, coffee. And you go and you direct towards, we'll talk more about orientation. You're gonna go right to the coffee thing and say, can I have a cup, right? Ultimate is all about evolution, all right? Obviously, which kind of question do you think I'm gonna ask? 3 and 4. It's always about why. Why? Right? You can think of proximate as what and how. But ultimate causation, questions 3 and 4, is why is that animal performing that behavior? Why is it still performing the behavior now? Under what condition did this behavior evolve so that it's really beneficial and every individual of that species performs that behavior? It's all about evolution. Why, and why? All right? Okay. Why do the flatwings, why do females in the cricket, what do the females crickets do? What is the evolutionary strategy of female field crickets in Hawaii?
They have to walk around more, and they also have to be willing to be.
Well, that's only if there are no normal singing male. If there are normal, what is under normal condition when you have a normal male and a normal female? Why do normal males sing? Because, exactly. Why do females go to a singing male? In order to have sex, right? Or interbreed, right? So the question is why? Why is there a change in behavior when there are no singing males? Because the flatwing and the female have to find a mate, right? They have to find that one singing male. So they have evolutionarily and very rapidly, in about 10, 15 years, changed their behavior. The ones who did not change their behavior, the females that say, I'm going to sit here and wait till I hear a singing male. Is that successful if there are no singing males around? No. But some individuals, remember the great tip, it's like those geese. Some are risk-taking. They're gonna walk around and, oh my God, there's a male, but he's not singing, let's have sex, right? The others are going, I'm gonna sit here and wait. I don't hear anything. So every species has a huge range of behavior. Not a huge range, but some are going to be faster, some are going to be slower, some are going to be in the middle. So that you always want a range because you never know with the environment. The environment is unpredictable, right? There were always females that like to walk around, right? Maybe they're not a lot, but they always walked around. Now is a successful behavior because there are no more singing males, right? Everybody understand? So it's not always clear cut. This is the nice thing about behavior and evolution. It's not, we draw the line, everybody has it, nobody has it, right? You want to have the whole range. So I'm gonna do a study where I actually touch on some proximate, but a lot of ultimate. And it's a big, long study, it's very interesting, and you're gonna have to think and ask, and I'm gonna ask you lots of questions. So this first study is with Dr. Hill, and he studies the house finch. You know what a house finch is? It's a fish. No, it's not. It's a bird. Proximate mexicanus. You want me to draw a bird? Everybody wants me to draw a bird. Voila! The house finch. All right? It occasionally looks like the bee and the fly, but in this case, this is the house finch. All right? They are distributed originally, long time ago, you know this word, mexicanus. They are distributed from Mexico to Oregon. But they have now flown further east all the way to New Jersey. But they originally were in Mexico. Dr. Hill studied this in two populations. He studied this in Alabama, and he studied this in Montana. So I want to add in the concept of ecology. You guys all know what ecology is, right? So what you have to understand is this is one species, the house finch, okay, C. mexicanus. It is found throughout most of the United States and Mexico. But you do know that a house finch in New Jersey is exposed to different kind of environment than a house finch in Texas and a house finch in Mexico. Everybody understand that, right? This is why Dr. Hill studied two different populations, because you are the same species, all right? So you do know that the junk food that they present to us in New Jersey, they do surveys, all right? There used to be a store on Cook where they had all kinds of potato chips. And a grad student and I would go there and buy a bag. And then after months, we would go there and that particular flavor was gone. We said, what the hell? We had to buy another flavor. Then after a while, we figured out they were testing. They wanted to see, do we like hot chips in New Jersey, right? Do we like salt and vinegar? Do we like this? So they do this because people in New Jersey like different junk food than people in Texas, right? Should we mate and have sex with somebody from Texas? It's not, all right? They're all crazy down there. But we're the same species. So these are the same species. But the environment affects you because I am only accessing this much food. It's like, I'll give you an example. The rats in New York eat pizza, they eat bagels, they eat tacos, right? The same rat species in an Iowa cornfield is going, hello, can I get a big pizza? No, they can't. They are still the same rat, but they have adapted to their local environment, right? Based on what the ecology and their resources. So keep this in mind. Now, most male birds are colorful in the United States. Everybody knows this, right? What about female birds? What color are they generally? Yes. Brown, gray, blah. Blah, 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 blah. They're not colorful, all right? In addition, in the United States, on average, the males sing and the females go like this. Come on, let's see you do something, right? What is surprising, which I just learned about a year or so ago, in Australia, both the males and females of every species sing. So islands are very, very different, right? So the females sing. Very few female birds in the United States sing. That's because we're all lazy. We say, come on, guy, dance, all right? So if ladies, when you go to a bar, you say to a guy, come on, let's see you dance, you sing. Okay, you're not mateable, go to the next one, right? So in the case of the house finch, the males have a red head, red throat, and red feathers on their. So they have red coloration on their head, throat, and chest. The females do not, all right? I'm gonna show you a picture. Oh, before I do this, I love this study. They did it in Europe, but they also repeated it in the United States, in New York City, in fact. So, in cities, not in Iowa cornfield, they found that a whole bunch of birds were picking up cigarette butts. Do not, you guys, everybody, if you smoke a cigarette, drop your cigarette butts on the street so that the birds can do it. They found all these birds were lining their nests with cigarettes. And guess what? Was it better or worse for their offspring?
Worse.
Who said worse? Come on, people. If you don't vote, I'm going to be upset. Vote. Who thinks it's worse? Put up your hand high. Who thinks it's better? Why?
Like more resources.
Oh yes, my favorite thing as a bird was to eat tobacco. More resources. Well, you're right, but you're wrong. Yes?
Deters pests.
Huh?
Deters pests.
Yes. So it turns out nicotine is very bad. So I hope you guys are not vaping. And if you have something very special to vape, you can meet me afterwards. So nicotine is very, very, very bad, right? Everybody knows this, right? The American Health Association. So nicotine is bad, and it will kill bacteria and all kinds of mites. So by accident, some ridiculous bird said, hey, the male comes home with a cigarette, and the female bird goes, what the hell? They go, I don't know. Maybe it could be good on this. Who knows? Now, did the birds go online to figure out that cigarettes are good? No. But for some reason, some birds have a behavior, and this is passed down. The female, if it mates with a different male next year, will say, hey, guy, go get me some cigarettes. Okay, right? So again, will you find this in an Iowa cornfield? No. Will you find it out in the desert of New Mexico? How many cigarette butts are there? I don't know. Maybe among dead people. So these birds in Europe will take the spikes off the top of high-rises because the high-rises don't want birds. They don't want bird shit because the birds shit down the windows, right? Typical European. We all wouldn't do that, right? So you know what the birds were doing? They were using these spikes. They would pull them off and use it as support for their nests, right? Again, evolutionarily, in the year 400 million years ago, did the bird say, hey, in 2020, if there are spikes up there, get it? If there's cigarette butts, get it, right? So this is the variation in behavior, right? All birds have to collect material for the nest. Some, for some crazy reason, said, I don't feel like going all the way to Central Park. Let me just get a nail, right? And they found that, and it turns out that this was also beneficial because some predatory birds could not get into the eggs of these smaller birds, right? Again, it's adapting to the local. Exactly. All right, Tim Bergen, Lorenz, Conrad, Carl von Fritz. Oh my God, what is he doing? He's smoking a cigarette. All right. All right. Who's the male? Who's the female? Yes. Isn't my drawing exactly like that? Yes. Thank you. Of course, you guys will all get an A, right? So, in the United States, they are very distinctive looking. All right. So keep that in mind. All right? So everybody has that in mind. So the question is, let's see if anybody has the first question. I'm going to give you the first question. It's under approximate. What is the direct cause of the red plumage on male house finch? Of course, there's a second question. What is the A? There's an A and B. What is B? Someone tell me what the second question is.
Benefit. What's the benefit?
Huh?
What's the direct benefit of?
No, not yet. What is one thing that is missing in this one thing? I said specifically what?
Why is there red plumage?
No, not why is there red plumage?
How the bird develops.
No.
How did the
What is missing? What is the one word here that I should not put in if it really applies to everything? Male. Did I say what is the direct cause of red plumage on house finch? Or did I say what is the direct cause of red plumage on male house finch? So what's the second question? Why doesn't the females have red plumage? Right? Did you see the picture? Do females have red plumage? No. Okay, so let's ask the question. What is the direct cause of male plumage on the house finch? Okay, let's think about this. It is a physical trait, right? Is there any case in humans where there's a male color that there's not a female that also has the same color hair? Are there black hair on males? Yes. Are there black hair on females? Yes. Are there blondes on males? Yes. Are there blondes on female? Yes. You want me to go through all the colors? Are there red on males' hair? Yes. Are there red on female hairs? Yes. So, what's the direct cause? Someone tell me what could potentially be the direct cause why there is red plumage only on the males?
Maybe because the females are, like if the males are brighter colors, so it might be easier for predators to spot
But
them.
I know, that's true, but why are the males? I just gave you the reason why all humans have the same hair color regardless of sex. Yes, you. Yes, you.
indicator of like strength?
No, I need the direct. What is the direct reason? What is the direct reason? Oh, not you. You answered too many times. Yes.
To distinguish between males and females.
No, that's not a direct reason. Let me give you an example. Does the male tap dance more than the female, and that's why he's got red plumage? That's a direct reason. So we're not talking about the why. We're going to get to the why. We're talking about proximate. You have your hand up. What is it? Give me an answer. It doesn't matter.
Maybe because the females have the nest and the nest is brown. So it camouflages.
Well, that's a very bad male because he's not taking care of female and the eggs. All right. Wow.
Is it just found the Y chromosome?
Y chromosome. Let me put it down. That's not the right answer, but we're going to put down something sensible besides. Is it sex linked? Wait. You already answered. So who has not answered the question? Who's brave? So I can laugh at you. All right, answer.
Male to male competition. They're competing.
That's not a direct thing. But how does it make it red?
Um,
I'm not wearing anything red. I may have red on the camera, I'm not sure. Yes.
just like the genetics, like,
No.
Is it so that the females can
That's
spot
not the why. That's not the direct reason. Why, yes?
Is it
right. No? All right? I'm going to tell you the answer because you guys are all losers. All right? Put that down and put it up on Facebook somewhere. Dr. Sotelo called us all losers because you are. All right? Because all of you are giving me why. That's great. That's question 3 and 4. All right? But the direct reason the males have red plumage is not sex-linked. All right? It's because of food. All right? So it's diet. Specifically their diet. What do house finch eat? All right? They eat seeds. They eat fruits. All kinds of fruits. They eat cherries. They eat apricot. They eat pears. They eat strawberries. Anything. They eat plums. All right? Now, of those that I've shown you, what are the color of these things? What color is a pear? Generally, don't go well, depends if it's a ball. So, what is so special is that there are certain foods that contain a pigment. And does anybody know the color of the pigment? Everybody say it. Yes. So what is the red pigment called? Well, it's actually orange, but it's carotenoid. Has anybody ever heard of carotenoid? Yes? Ha! You guys are still losers, all right? Think about this. All right. So it turns out that it is not genetic, it's not sex-linked. The reason why males have red feathers is because they eat carotenoid foods, all right? So what's the next question you should have? What the hell are the females doing? Oh, I hear silence. Nobody's putting up their hand. Oh, it's because, no. Right? So, they are out there, the males and female. Do they seem to have different foraging behavior? You know, at the rate you guys are going, I'm not going to get through this lecture until December. Do males and females have different foraging behaviors? Do females avoid what? Carotenoid foods? Do males specifically find carotenoid foods? Right? These are the proximate questions that Dr. Hill had to ask. So out in the wild, they observe certain things. Okay? They observe that males will go and look for carotenoid food along with other foods. Okay? So the males will fly around looking for carotenoid containing foods. Let's do a cost-benefit analysis of this, all right? Cost, benefit. Is there a cost for the male to be flying around looking for carotenoid foods? Remember, they observed this. Yes, back there.
It could be like a waste of energy if there's not a lot of it.
Say it louder. What?
A waste of energy if there's not a lot of it available.
Yes, there's a cost. There is an energy usage. What's another cost? Is there another cost? Yes?
Limited food options.
They eat everything, but they also seek carotenoid foods. Predator? What were you gonna say? Say, increase predator contact. Yes,
Can the fact that these are seasonal foods?
they migrate. Yes, it is seasonal, but they're gone when it's winter here, all right? Is there a benefit? Let's leave it as a question mark because you guys are all losers, you won't figure it out. All right, so males, by observation, seem to fly around and seek out carotenoid containing, red, orange containing foods, okay? All right. Females, Dr. Hill observed, these are all field studies. Females, what they are trying to do, because they're smart, is, let me write this down perfectly. The female foraging strategy is to maximize, never get between a woman and a buffet table. Keep that in mind. Maximize calories per unit time of foraging. What's another way of saying this? Do not get between a female and the food table, all right? How many of you guys will let a woman go in front of you, right? Why does the female want to maximize her calorie? Why? Exactly. Don't forget, this is in the spring. They are building their nests or whatever. The female, when we talk about it next week, the female, the more calories she has, the more yolk she can put into her damn eggs. The more yolk, the greater the chance of that chick developing and surviving and hatching and surviving, and you have increased reproductive success, right? It's always like this. You starve a bird, she produces no eggs or very small eggs with very, very little yolk. You stuff the bird with lots and lots and lots of food, they produce more eggs and more yolk and increased survival for all the chicks, right? So, what female house finch do in the wild is that they find a patch of food, regardless of the color, they are going to stuff their face, all right? Has anybody got a bird feeder at home? Yes? What, on average, do you see very brownish, boring color of birds, or do you see a lot of colorful males? What do you think the answer is? You know, bird feeder, do you want me to draw a bird feeder? What color are the seeds generally in a bird feeder? Brown. Oh, what was the word again? Brown. How many males are going to be there? On average, you're going to find more females at a bird feeder because they don't care. They want to eat and eat and eat and eat and eat. When we talk about this, you'll find out that a lot of females in the species will lose 70 or more percent of their body weight in order to lay their eggs and everything. So they have to eat a lot. If you all lost 70% of your body weight as is, you're going to be dead. So you have to increase your intake so that you can give 70%, 50% of your body weight into the yolk, all right? So, is there a difference in foraging behavior between the male and the female? Yes. Can that explain why the males tend to have a redder chest than the females? Yes. What would be the perfect experiment in the lab? So, this is all observation. One, observation. Two, experiment. Let me see if I have the pictures of these things in the right sequence. Oh, look! Red, 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 red. Oh, you do know that there, way back in the 80s and 70s, there was this fad that you can lose a lot of weight if all you eat is carrots. Well, of course you're going to lose a lot of weight if all you eat is carrots. But people's skin started turning orangey, okay? It's not a good sexual allure for people, okay? If you saw somebody named orange color. Again, this bird right here? Can you tell what color the chest is? Does it look like it's got a lot of red? No, right? So, on average, do you see in the bird feeder, do you see anything red? So if you want to attract a male bird, put something red in there, right? So on average, there is one male, but there are 3 females. So every single bird, especially the female, is going to maximize their calorie per unit time foraging. The males will eat depending on the location, right? And the reason why he chose these 2 is because between Alabama and Montana, the males have different intensity of redness. We haven't gone to that, all right? And it's normal. In Montana, it's not that much. In Alabama, it's redder. So again, right, they are all looking to maximize their food intake. Nobody puts a bird feeder out in December because they're all gone, right? Everybody understand? All right. So how would you do this experiment? Yes?
I have a question. If,
Yes.
like in a lab setting, you fed like the female birds like high carrot.
Oh, very good. So what is that? Is that what the second? Is that what an experiment is?
Oh, is it?
Yes.
Oh, okay.
Oh, you're so smart. Everybody else is a loser. Yes.
I actually wanted to ask a second question.
Yes. That's what I'm going to do now. Go ask.
If the female finches eat everything that they can, might they also eat the carotenoid?
But if you find a blueberry patch, what are you going to do with your female house finch? You're going to stuff your face, right? You're not going to say, oh, there's a big blueberry patch, but half a mile away I see a red patch. You as a female are going, get away from me. I'm eating all the blueberries, right? If they find a red patch, they could. But red berries are rarer than all kinds of other things like seeds.
Okay, thank you.
Yes. So the experiment is to say, is it really true that only males can turn red? Is that right? Is it also some kind of genetic thing, right? So the question is, what would happen if you fed males and females carotenoid food? What's the other control? Yes. What would happen if you fed male and female no carotenoid foods? Anybody want to guess what the results are? I think I went ahead of myself. Okay, good. So what they did was they captured males and females from the wild. All birds were returned to the wild unharmed, except the ones that they ate, but don't worry about that. All right? They had two groups. You can guess what's in group A and group B. In group A, the males and the females were given carotenoid foods. In group B, the males and the females, notice it's a plus, it's not a multiply sign. Multiply signs mean they're having sex. This is not sex. The males and females were given no carotenoid foods. They were given other food. Do not be under the impression that they were starving, all right? Tell me what the color of the male here, this one right here. What's the color of the male? Red. What's the color of the female here? What's the color of the male here? This one right here. What's the color of the male? Brown. What's the color of the female? So answer my question. What is the proximate causation of red plumage in male house Finch. Everybody say it. Exactly. Just food in general? Carotenoid containing food, all right? So, in the lab, what did they find? They find that if males and females ate carotenoid food, they all turn red. If you took males and females and you gave them sunflower seeds, which has no carotenoid, the males look identical to females. There was not any red plumage. So what's the direct cost? What's the direct reason for male plumage? So the direct reason everybody got it? Yes. All right. So what question are we on now? 3. Why do males have red plumage? We've already answered the question 1. What is the mechanism? The mechanism is that the male's forage behavior is different. They actively seek. They take a huge cost to go out and find red things in their environment. They may have to travel across the street, half a mile, who knows. The females are going like, I see a blueberry patch and the sunflower seeds, I'm staying here, all right? So, why do males have red plumage? Or why do males want red plumage? Why? Why? Oh. So these silly males are doing it just because the female's going like, I like a little red chest, all right? So that is exactly what's going on. Getting down to the evolutionary reason. Why does the male take all this cost, risk, to fly around to look for red plumage, red food, all right, carotenoid foods? It's because the female wants it. We're getting to sexual selection. Ladies, it's a women's studies course, all right? It's all because of us. It's whatever we want, you guys, thanks, all right? But the problem is that not is every male successful in getting enough red carotenoid foods to make the chest really red. Are all males equally successful and gorgeous and smart and rich? Looking at this population, I'm not going to say anything. All right, ladies, mate with somebody outside of this class. All right, go to the business school, suck up to some guy, even though he's ugly. He's going to make a lot of money. All right. All right. So then the question is, what is the next question, all right? So we guessing that the females want the males to it, because why else would you explain that they're taking all this cost and risk of flying around, getting eaten by a hawk, an owl, getting hit by a train or whatever, just to get red plumage? Because if they don't find red carotenoid food, they look exactly like a female, all right? So what would be the experiment? Let's see who's smart enough. Anybody think of an experiment in the lab now that you have all these damn birds?
With the male, which is still look for carotenoid foods if there's a red present the females with brown and red males.
Oh, very good. You notice it's the females that have the answer. Yes. So the question is, obviously, we can conclude that a female wants the red breast, because that's the only reason why these stupid males are going like, let's go fly far away and get red breast. So is there a difference in if a female gets presented by multiple different shades of male? What shade will the female always pick? Right. So here's the experiment. It is brilliant experiment, all right? So what they did was they took red wild males, all right? So they catch them, this is the same experiment, they didn't release them, come back. So they took the red males that had, the males that were wild that had very red breasts, all right? Here's the experiment they did. Half of them, and they did it both times, half of them, they made redder. So they took some males and they spray painted more redness on their plumage. What did they do with the other half of the red males? I have no way of doing this color. They put baby powder on them to make them lighter red. Got it? Don't you love behavior? I love behavior. This is so fascinating. Everybody skip medical school, go to behavior and PhD, all right? So, now, they're brilliant. Dr. Behill was brilliant because he got a whole bunch of wild males. Some of them are different color intensity, all right? But he doesn't care because the same individual, he can make redder and then wash it off, and he can make it whiter and wash it off. Everybody got this, right? So, what's the experiment? So, what he then did was he took the two contrasting males, so you have the row. He put the redder male in the cage, he put the lighter male in the cage, and then he put a female into the cage, and they waited. Which males all the females, through many experiments, which males did the female always said, come to my cage, let's do a little nasties. Which males did they always pick in every single case? Exactly. It doesn't matter what the male originally had. So they could have gotten a very light red male, made it redder, that's the one that a female picked. They could have gotten a really red male and made it whiter, that's not the one that a female picked. So, why do males want to have red plumage? You can all say it. What? To reproduce? That's the sex paper. We're not going to talk about that. Why do males want red plumage? Because the females want it. And the redder, the better. All right? So if the female is out in the wild and sees two red males, which one is she going to say, let's have sex? The redder one, right? So is there a benefit? Let's go all the way here. Where was it? Is there a benefit for the male to risk his life against predators and energy expenditure and flying around to go and get carotenoid food? Is there a benefit? Is it huge? Yes, it is huge, huge, huge. Huge, huge. Because that leads to reproductive success, all right? They did experiments over and over again in Montana and in Alabama, all right? And in every manipulation, in every single female, if she's given a visual choice, because, oh, wait a minute, let me ask a question. Do birds have eyes? Can they see? Can they compare? Yes, yes, yes. So, given any choice, the female will always pick the redder male regardless of what the manipulation is. So if you were a house finch and you're too lazy to go and fly and get carotenoid food, go on Uber Eats, order some red dye, and stand there going like, come get me, right? All right, so we now know the ultimate reason for all this is because the females want males with red plumage. And the redder, the better. So, yes, but there's no but.
Couldn't you ask them why do the females want that?
Oh, I didn't want to tell her, but you know what? I can speak house Finch. Okay, let's go back, and I forgot I wanted to mention something. Very, very carefully. Anthropomorphism is attribution of human traits, feelings, and behavior to non-human animals or nature. So people say, oh, that was a nasty storm. Was that really a nasty storm? Do storms all gather somewhere up in heaven somewhere and say, you be nasty, you be nice, you be okay? So we are not going to try to be anthropomorphic, all right? We are trying to look at the reason. Like, why do males have red plumage? Because they fly to look for red carotenoid food. We've already figured that out. Why do they want to have red plumage? It's because the females want red plumage, all right? They want it not because I want it. There's a reason why, all right? So now the question is, what does the female get when she gets a male with a very red plumage, all right? What are we up to, 4? So we are not going to try to put all kinds of, here's the lazy bird. I really shouldn't have done the bold and shy, but the paper used the word bold and shy. It should be fast, a slow approach to a foreign object, because that then eliminates the whole like, you know, does anybody have a cat? Yes. And everybody has all these things, oh, she's really nasty, she's mean, she's spiteful. I have a friend who's a husband and wife. The wife loves cats. The husband does not like cats, all right? There's one cat named Murphy that will only pee in his shoe if he leaves it out, only. And the cat, will look at the guy and go like this. Is that spiteful? I think it is spiteful. But for some reason, it's a male dominance. It was a male cat. This is the husband. Here's my mommy. What are you sleeping with my mommy, all right? Think about this. So now the question is, why does the female want a red plumage? What does it actually say about that male? The question is, why do females want males with very red plumage? Why do they want it? Are you going to give me a why? Give me one reason.
The brighter they are, they have a higher chance of survival.
It could be. Okay, so you're saying maybe it's higher survival. You had a what?
That they're like stronger hunters.
Stronger hunters.
More efficient foragers.
More efficient forager. Ooh. They're good foragers.
It shows that they're willing to put in the work.
Put in the work. Are you guys putting in the work to come to this anthropomorphic, putting in the word. What's another way of saying it that has no human attribute? Are they more risk takers? Persistent, risk-taking. Are they willing to fly far and wide to get the red berries?
Bold.
Bold. Okay. Anybody else have anything? Oh, that bagel looks good. Notice she offered me a bite. No. They're in better shape. Okay. Physically. Do you know this for a fact? So, if you had a boyfriend or girlfriend or whatever, how do you know that individual that you're potentially going to marry is going to provide you until you drop dead? Can any of you be certain that your potential mate is going to be a great parent? Can you? Can you ask them for their little bit of DNA? So all you ladies, what you should do is just accidentally nick your potential boyfriend or whoever you're going to mate with. Say, oh, it's okay. Let me just get a little slide. But that's all right. I'll dispose of it. Send it off to 23andMe and find out all the potential cancer things. But does that tell you that they're going to be a good father? That they're not going to beat up your children? That they have good sperm? Right? So, yes, but how do you know this? Just because they have red breasts, does that mean they're going to be good parents? Can anybody be sure? You can't, right? And we're humans. We can go up to the guy and go, are you going to be a good father? Yeah, sure. Oh, I got to work. Oh, bye. Oh. And then they ghost you, and then that's it. And you never see them again, right? All of you, right? So, this is a difficult situation. We're going to talk a lot about that in the next lecture on sexual selection. How can you guarantee you only live for, let's say, 6 weeks? That's all you're going to live. How do you guarantee, and you're female, how do you guarantee that that male has good sperm and that you're going to have good offspring? What's the guarantee? What are you looking for, right? Anybody know? You only live for 6 weeks and you didn't give me your bagel. Not after your germs.
You probably want someone that's like well fed, so that they're like,
We already got the physical.
yeah, I feel like that's
But how many well-fed men have ditched their wives and their children? Many well-fed men. Yes. I'm not making any comments, but looks does not mean that you are going to be a good parent, mother or father, right? Intelligence? No. Money? I'll do anything for money, all right? So, it turns out that there are signals, all right? We're going to talk about them. They're proxy signals. There are signals that a red plumage bird that is redder than another one is potentially a better mate, right? So in all of this thing, we're not talking about, oh, put more work into it. They can visually see and make a comparison, all right? We're not going to talk about a neural mechanism. But if a female is exposed to a red male and a very light red male, the female makes a choice, all right? So Dr. Hill, in fact, found 3 reasons why the redder males, on average, is better than a lighter red male. There were 3 reasons the redder males are, I'm going to use the word better, but more successful, okay? Maybe more successful than lighter red males. Remember, everything is a comparison. If you find one male, one female, what can you say? She found the male, right? So in this world, in this population, the females are looking at all the males. The males are all doing their own thing. So there is always a comparison. So the females can compare, the males can look at each other. How many people have seen documentaries where males fight each other, right? So at some point, a young punk male, who's maybe a little smaller, comes up to the alpha male, right? And he goes, I want your women. I want your females. And the alpha male goes, okay, done. I'm still king of the heat, right? But at some point, he's going to get old, and some young punk is going to beat him up. But there's an assessment. A new young male is going to look at that big, huge silverback gorilla and go, oh, I'll wait a few more years, all right? So they can make comparisons. And in fact, you'll find that many animals can count better than us, all right? So here are the 3 reasons. 1, all birds are susceptible to bacterial infections. Have all of us had a bacterial infection? Yes. Is everybody so pure and so safe that never had a single bacterial infection? Of course not, right? So the bacterial infection is Mycoplasma galli-septum. Galli means bird, chicken, galley, all right? So it's a very, very, very common bacterial infection. And they get it in their eyes. How many's had an eye infection in their childhood, right? It's very, very contagious. So if I'm a male and I have an infection, I will pass it on to my female. I will pass it on to the chicks, all right? Right? Bacterial infections are very, very contagious. So guess what? Turns out the redder males will rid the infection faster. He didn't go into, don't forget, he's a behavioral biologist. He didn't go to the whole physiology and DNA. This is long before that, right? So maybe there's something about the carotenoid. Maybe the fact that they're huge and beautiful and red means they've got a huge, good immune response. They have good vision. They can spot the red berry half a mile away. They can fly there, avoid all predators. So they are the supreme male. Ladies, don't go for them because they're all dumb, all right? They have no IQ, but they just have a gorgeous body, right? So they rid the infection faster than a lighter male. So they have a very, very, very good immune system. IS, I'm not going to write it out, immune system. So maybe it's the carotenoid foods, maybe there's some compound in them that helps them, maybe it's the whole combination of everything, right? And the way they did this, okay, and I'm not going to write it down, is they actually infected these birds, the males that were very red and the males that were less red, and they timed how long it took them to get rid of the infection. Like how many of you get colds but get through them really fast? How many of you take a long time? Like everybody gets through it in a day and a half and you're like 5 days going like this, right? Stay away from it, all right? So everybody's immune system is differently. But for some reason, the redder males get rid of it faster. And you want it to be fast because you don't want to infect your spouse and your offspring chicks. Second, in fact, the redder males provide more parental care. That means they feed the offspring, they feed more. So they're already the jocks of the world. They're flying half a mile to get a whole bush full of red berries. They are gorgeous. They have a big chest. They're all red. They walk around like this. Come mate with me. Come have sex with me. Because I will provide for your offspring. Because I'm going to fly far away, bring the red berries. I'm going to fly far away, give you some other berries. All kinds of stuff. So it turns out that they are, again, this is all out in the field, all right? And in the field, they did the whole experiments already out in the field of by observation that the redder males tend to spend more time feeding the young, which is parental care, right? Everybody got that? Who wants this? Oh, nobody else? Of all the females, who wants their mate to provide a lot of parental care? Who doesn't give a shit because they're all going to be great by themselves? Okay, all right. What's the third reason? So there seems to be a reason why the females, through evolutionary adaptation, whatever the reason is, they have picked the redder male, and they pass on these traits, all right? So it turns out that females just prefer redder males. We will get to this. So I'll jump ahead and tell you that males and females of one sex have all similar traits. We all have eyes, we have heart. Those males and female birds all have beaks, they have feathers, they have legs, blah, 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 right? But in terms of behavior, males inherited their certain behavior from their father. The females inherit certain behavioral preference from their mother. So the mother prefers redder females. What does the female offspring also prefer? It's passed on, all right? They are not like somebody talking. Like, guess what, ladies? You need to get a redder, right? So there is encoding of something. We can't find the genes because these people aren't geneticists, all right? They're not doing that kind of stuff. And nobody, CDC, is not going to give them, or NIH is going to give them to figure out why female house finch are passing on this stuff. But the fact is, the female offspring want redder males because the mother wants redder males and the grandmother wants redder males. The males are passing on traits that says, be big, be alert, have good heart, good wings. I'm going to find that patch of red berries and I'm going to eat it because I need to have reproductive success, all right? It's all about reproductive success. So the less red male will get some, but maybe it's the last female because all the other redder males have already been picked, right? So ultimately, everything in terms of ultimate is reproductive success. How many offspring did you produce compared to another male? See, they get very, 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 it's disgusting, right? These are not even the worst pictures because I don't want to gross anybody out, right? But the point is that it's like red eye, right? Pink eye. It is very, very contagious. You're in a nest with your female and you're in your nest with your little chickies, all right? The faster you get rid of your cold, your bacterial infection, your viral infection, the less likely that maybe the others won't get infected, right? Now, for some reason, the redder males get sick too, but they get rid of it very fast. The less red take longer. The longer it takes for me to get rid of it, the more likely that my brother, my sister, my mom and dad, my babies all are going to get infected, right? Everybody must have a place where you sometimes one person in the family comes in with a and then it just spreads throughout the whole family, right? You don't want that. You want maybe to get rid of it as fast, maybe only one other person gets infected. Now, the reason why is, look at this. These are the same species, but one is found in Michigan, one is found in Mexico, and one is found somewhere out in the desert in Mexico, all right? Are they all equally red? But what the females are doing is the population in Michigan are comparing males. The population in Mexico are also comparing males. The Mexican females are not getting on Facebook and saying, oh, look at that one from Michigan. Why aren't he here, right? So there's the ecology. They are out in the desert. There are no red berries, right? So they are the yellow variant, all right? They're all house finch. They're the same species, but they are adapting to some local environment. So if you're a female in that thing and you're looking for a red male, you're in trouble. All right? There are no red males there, so you're not going to mate. So there's going to be local adaptation, but they're all the same species. Everybody got it? And all this local adaptation is going to affect your behavior. Ah, who's better looking? Who wears red ties? Somebody poor who's living out of his car, or somebody famous, right? Is red a power color? Yes. How many of you get gray lipsticks? I'm talking to the guys. Okay, no. How many? No. If you want to be sexy, what do you put on? Red lipsticks, right? So red, even for humans, is a very, very powerful color, right? So if we can distinguish it, if the house finch can distinguish it, we damn well can distinguish a red. All the business people all wear red ties, right? Oh, Kanye, this is before he went crazy. I used to like him when his first album, and then he just went crazy, and then you know, right? All right, so red is a very, very, very important color. All right, shall we keep going? Yes? Yes. You have a question?
I was gonna ask, is there, how come it's just red? Like, could this happen with like blue for blueberries or something, depending on where they are?
No, it's, and you know what? Let me ask you a question. Can birds see color? Who said no? Can birds see color? Yes. No, it just happens to be something to do with red and carotenoid, right? Now, don't forget that yellow variant, they don't get exposed to red carotenoid. So locally, so if you are in a local place where there's absolutely no red thing and it's been like that forever, there's going to be a difference in the color. No, but no, blue doesn't really. Blue is a very, very odd color. So there's nothing really blue. It's all have to do with the reflecting of the lights. Red is red, all right? So, does everybody understand the proximate and ultimate questions? Everything is always down to reproductive success. What are you in that population? The reddest male, the medium male, or the light red males, right? If your female has a choice, they're always going to pick that one, right? But sometimes all you have is the ugly pale male.
So in that environment with the yellow variant, do they pick the yellow one?
Yes, they pick something slightly different. But then what we're going to talk about on next Wednesday is something called female mate choice. All right, guys? Ultimately, even for humans, the females have to say yes. Am I right? What do the classic males do when they want to propose to a female? And what does a female go? Oh my God. You got to be very careful. You don't want to be in a jumbotron and a woman goes like this. You want to go, oh yes! I mean, what is Taylor Swift going to do? How much money is he going to have? All right. So let's, let me see, we did all this. All right. So let's talk about innate behavior, which is something that Tim Bergen and Conrad Lorenz did. Someone give me the definition of innate. Someone give me, okay. No, not the people, somebody you. Naturally there. Are you naturally that smart? Give me an example of an innate behavior. You, yeah. Yeah, you, yes. Give me a human innate behavior. Not all babies cry when they're born. When I came out, I said, what the hell? Babies cry, no, not quite. Not all babies cry. Especially with their blue ones and they have to do CPR. Yes. They will grip, right. You know who's our closest ancestor? I hope you guys all believe in evolution, right? I had a kid a couple years ago, came to me at the end of October to have a long little chat. And we were talking, and he said he enjoyed the class. But he said to me, you know, I don't believe in evolution. I said, you sat through all this and you don't believe in evolution? Anyway, so who's our closest ancestor?
Bonobos?
And chimpanzees, about 6 million years apart. We were evolutionarily, in case anybody doesn't, you ate the whole bagel, now you have to go to the bathroom? All right, so we are arboreal ancestors. Arboreal means tree dwelling. So our ancestors from a long time ago all lived in a tree, right? If you take a newborn baby, now don't go to a hospital and kidnap the baby and try this. Or your aunt and uncle will have a newborn, let me try this. But soon after birth, in a very short window, if you take the baby, and this is the head of the baby, and this is the butt, and you tipped it like this so the head is lower than the butt, the arms go like this, right? It is an innate evolutionary thing that we've kept from living in a tree. Because if you fall out of a tree, you die, right? There are tigers and lions, and they're going like, come on, fall out of the tree, come on, right? So it's an ancestral thing that if your head is lower than your butt, you better grab onto a branch. We still have this, but not as a 5-year-old, and certainly not at your age. If I tip you, you probably punch me, right? So those are innate behavior, right? You have them. So Tim Burden and Lorenz gave a definition of innate behavior. So what is innate behavior? Oh, you can also do it to a newborn, a relatively newborn, like a couple of weeks old. If you hold them by their armpit and you let their legs fall onto a table, they will go like this. It's an innate behavior, but they don't walk until they're 1 year old, but if there's enough pressure, they will do this automatically. These are innate behavior in humans. Not picking your nose, okay? All right, what are the characteristics? One, they're heritable. You guys know what all that means, right? I don't have to explain it. That these things are encoded in genes. Passed from parent to offspring. So innate behavior is actually encoded in genes. You pass it on. It has to be something so that in those species of birds, they know the song as soon as they come out, all right? In other species, they have genes that allows them to learn a song. So we all learn English and math and all kinds of stuff. That's because we have a whole suite of genes, many, many genes, that allows us to process visual information, auditory information, our tongues move, blah, blah, blah. Oh, I have another one. Do you know why babies don't speak until like about 1.5 years, 2? Anybody know why? We can certainly speak, but we don't speak anything that la, 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 la. I always, when my kids were little, I go, oh yeah, really? You know, and they all go, la, 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 and I go, I have no idea what they said. But do you know why we can't enunciate whatever language? Anybody want to guess? Because they're stupid? Their tongues better not be too large for the vocal cord. No! Guess what? Yes?
There's a critical period in language acquisition when you're a child, you have to learn to be able to pronounce it.
Yes, but, okay, I agree with you, but why can't they enunciate clearly nonsense? You know why? It's because it takes about 1 year for all the nerves to go to the tongue and the throat and the jaw to myelinate. Without myelination, you guys remember general bio and the nervous system, action potential, neurons, myelin. It takes about 1 year for all that. So if demyelination, you get multiple sclerosis, right? So it takes a long time for the thing to myelinate, and once it's myelinated, they can then tell you, F off, Mom. And you're like, wow, okay, I know you don't want milk, let's go on, right? So they can babble, but they can't coordinate enough because they don't have myelin. That's the last of my info. All right, the point is all innate behaviors that we're going to be talking about in animals, and even in us, are heritable. We get it from our parents, and they got it from their parents. There's a long evolutionary reason. 2. Intrinsic. Now, what does intrinsic really mean? This is a very interesting. It means that animals raised in isolation, that means away from all individuals of same species, will perform the behavior perfectly. Is that a good definition of intrinsic? So this reaffirms that everything is heritable, it's encoded in the genes. So if you took a bird that will naturally sing by itself the right song, and you took the egg out of the nest, you brought it in the lab, and you kept it warm, and the chick came out, and you never make any noise, you never say anything to the bird hears nothing, what is that bird going to do? Is it going to sing? Yes or no? This is one of the ones that sing automatically when they come out of the egg. Will it sing? Yes. Will it sing the right song? Yes, because it is encoded in their genes, all right? So this is what intrinsic means. So there are occasional times in the past where they found children that have been abandoned as little infants out in the woods. They never quite learn something because, like you said, there is a critical period. But they can walk, they can grab food and put it in their mouth, they can see, but all the other acquisitional stuff requires other genes. But these ones are saying that if the bird can sing as soon as it hatches, and you take that egg and you raise it in isolation, it will hatch out in total silence, and it will sing the right song of its parents out there. That's an intrinsic behavior, right? Now, if you have a bird that requires to be learned, and you raise it in isolation, it's going to go, you know, it's going to make noise, but it's not going to make any sound. So if you took a child and you never expose it to anything, it's going to babble because you're going to go blah, 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 but it's not going to speak in English as we know because that requires other genes, right? And we don't care about development. It's stereotypic. Stereotypic means that it is essentially performed the same way each time. By individuals of the same species. So this is why they're called innate. That every time that animal does it, it's going to be exactly the same. Now, I know individuals of a species are going to have slight variation. But under no circumstances is there going to be an individual of that species who doesn't do it at all. Because that one is definitely in deep, deep trouble and will not get any reproductive success. There's something horribly, horribly wrong with that individual, all right? So you can put in brackets that, of course, there's going to be some variations, right? There's going to be some. Even in the great tit, even among the slowest, shyest individuals, sooner or later, they're going to go get the food, right? The variation in the great tit is how fast they are willing to approach a novel object. all right? So we don't want anything that is so exactly one way. There are going to be variation because sometimes some variant is going to be more successful in an environment. Another time, another 100 years, it's going to be some other variant. 4, it's inflexible. That means it's not modified by development or experience. All right, so these kind of behavior, we're not talking about a behavior where we're talking about learning, cognition, all that kind of stuff. We're talking about a narrow group called innate behaviors, right? They are innate, they are heritable, they're stereotypic, and they're inflexible because they have high reproductive success, all right? They are extremely beneficial for that species. They are all linked to high fitness. So over huge evolutionary time, you've gotten rid of all this unnecessary behavior. Unnecessary. It's not going to be successful. And you now have a suite of behavior that everybody does it almost the same. Has anybody seen those movies with penguins? Right? All the males put their eggs between their legs and cover it and stand there. Hi, how's it going? Yeah, how's your egg? Yeah, I've been rotating it between my right and left foot, right? Everybody does about the same. Some males may move a little bit more. They take their turn being on the outside where it's colder versus inside, but there is a particular suite of behavior. If the male penguin does not do that, will the egg survive? If the male drops it outside, goes somewhere, does a little crap and come back, will the egg survive? No, it's too bloody cold, all right? So they have calmed down certain behavior that is so critical to survival. And these are the suite we're talking about. Not like, oh, I heard a new sound, let me pick it up, right? And finally, the last characteristic is consummate. Consummate means that it is fully developed and expressed perfectly the first time it is performed. Remember, these are critical innate suite of behavior, right? There's no learning involved. It's encoded in your gene. You have to do it right the first time or you're not going to survive, all right? If you happen to be one of these animals that live on a cliff and an egg, right? Those birds that live on a cliff, when they hatch, they have to be very, very, very careful. They have to have a suite of behavior because if they fall out of the nest, because they're on a cliff, right? So they have very specific behavior that has been successful. So nobody moves, everybody waits until they are mature enough, and then the first time they come off the ledge, they fly perfectly. They don't go, oh my God, oh, like this. Because there's no second chance. You're on a cliff, right? Birds that are living on the ground, they get out, they go like, oh my God, what am I doing, right? So it all depends. So consummate means that the first time you perform it, it is exactly like all the others in your individuals and your species, and it is perfect. If it's not, you're a bad individual, you probably are something mutated and wrong, and you're not going to get mated, all right? All right, anybody have any, no questions? So those are the 5 characteristics of innate behavior, right? Now, part of the innate behavior is something called fixed action pattern. FAP. So in some of these behavior, they have a suite of behavior processes or whatever, and it's called fixed action pattern. So these are evolutionarily And I'm going to give you some examples. So again, these are innate behavior. When an animal is exposed to this specific stimuli under hundreds of million years of normal response, that animal will know exactly what to do because it's encoded in their genes, and the bird next to it, or the lizard next to it, or the fish next to it all does exactly the same thing. Because we are looking at optimum trade value, all right? The optimum trade value, remember that definition last week? They have, it's been culled from millions of years of adaptation, right? Nobody thinks that in the year 1990, someone's gonna put a little gummy in your cage and you're gonna go, oh my God, what is that? Nobody does that. But occasionally there may be weird objects in your area where you're looking for food, all right? So they are not doing a situation, what if my car doesn't start on the midterm for this one? What if I drop dead, and now what class are you going to take after I drop, right? What if it's snowing on October 5th when we have the exam? They don't do that because there's no what if. Evolution is going to be very parsimonious. It's going to say, when this happens, you got to do this. Because if you don't, you're going to die. And when this happens, you got to do this, otherwise the female is not going to go look for you. When this happens, you got to do this so that as a male, you're going to go and look for carotenoid food. So those house finches don't consider, well, I'm sitting near a house that has lots of bird feeder, but it's all brown. I'll just eat them. No, they are genetically programmed to go look for red carotenoid food. Why? Because the females want it. The females are genetically linked to look for a male that is redder because they have greater immune response, they have greater parental care, and I think you're sexy, right? So all three of those things are going to drive the females. All three of those things are going to drive the male to get a carotenoid food, right? Everybody got it? So let's do an example that Tim Bergen and Lorenz did. And it was more Tim Bergen, so I'll just write his name down. It's the gray lag goose egg retrieval behavior. Who has heard of this? Do not put up your hand anytime soon, okay? For the rest of the semester. All right? All right, so this is the behavior, and this is the FAP. All right. Let me tell you, the gray lag goose is a very, very large bird. It's over 8 pounds. It's a big bird. It's not one of your stupid little geese. They also have very, very large eggs, about 1/4 to 1/3 of a pound. So we can have like 2 gray lag goose eggs, and we can make an omelet for everybody. All right. They nest on the ground. Why are birds that nest on the ground have more interesting behavior than birds that nest in a tree? Anybody have an answer? Anybody have a thought? No, not you, somebody else. Exactly. When you're in a tree, you've eliminated all the ground-dwelling predators, all right? But you're in the ground, oh boy, you better have different behavioral strategy. Right? I'm up in a tree, I'm going like, there goes the wolf, there goes the dog, there goes the cat, right? All right. What am I going to draw? They are a big bird. This is the giraffe of birds, all right? So they make a kind of a straw grass. I'm going to draw the eggs red. They're not red. Everybody say it. The bird's egg is not red. I'm just drawing it for contrast, all right? All right? So they make a nest, and they sit on the eggs. Has anybody in elementary school hatched eggs in their class? Yes? My daughter was so scarred, so she must have been in grade 2 when the teacher did this whole thing with the eggs, right? And then they were in the little nook in the outside, and the little chickies were running around, and one boy accidentally backed up and stepped on. She never talked to that boy ever again. She was scarred. She goes, oh my God! Yes. So let me see. Let me show you. I don't want to go ahead and show you stuff that you're not ready for. See? Don't they have a long neck compared to the house finch? Everybody say yes. Look where their nests are, right? Kind of. See, that'd be the kind of bird, because I'm not big into housekeeping. Okay. So let's see what else is there. That's the egg. So how many eggs do you want in your omelet? That's a big omelet, right? So they are a big bird. They have big eggs. They make a nest on the ground. So what is the FAP? Okay, occasionally, because they're on the ground, and don't forget, the birds in all cases on the nest, on the tree, on the cliff, or on the ground, they have to keep the eggs, what's the word? Warm, right? Constantly. They have to keep them warm. If your eggs are exposed, that's it. That's why if you did that elementary school stuff, they have it in a little hot thing, and they're rotating it, and everything is warm, right? How many of you, when you were inside your mommy's tummy, it was not warm? Never, all right? So warmth is very, very important. And the female and or male together combine to sit on the eggs to keep it warm. Everybody got it, right? There's nobody who says, what's a bird? All right. So, but occasionally, because they're big birds and they have big butts, occasionally an egg will roll out. Okay? Occasionally, not often. Now, in terms of evolution and reproductive success and fitness, should the female leave it alone? Who votes yes? Who votes no? They better, yes. Okay, well, some of you are carrying, the rest of you go omelet. Right? So, the female or the male, depending on what it is, when they visually see their proximate cue, is seeing the egg outside of nest. Everybody got this? That's the trigger, all right? Actually, all right? So what does the gray-lag goose do, right? Should the gray-lag goose get up, walk over, and push the egg back into the nest? Who votes for that? Why not? Exactly. So what does a gray-lag goose do? The gray-lag goose, what it does is, because it's got a long, yes, will bend over. No, this is not a goose with two heads, all right? I know some people. Will bend over and will roll the egg back in. They don't have to get up that much. They may not even have to get up at all, but they will crane their beak over and roll the egg back in. So what they do is they will reach with their neck and beak to the egg and roll it back into nest. Everybody got it? Yes.
What if the egg is too far? Like they can't reach the
Stop.
egg?
I hate people who tell you who the murderer is. It's always me, okay? I want to tell you, all right? Sheesh. All right. Now, you distracted me. I've forgotten what the hell I have to do now. You're dead to me, all right? All right. So, now, when I say gray-eyed goose, and you see, your first time you see an egg outside, what do? No, you call Ghostbusters. Right? What do? Do you perform it or not? Absolutely. This is what they mean by consummate and inflexible and stereotypical. Nobody taught it. Every first time, mother or father gray-eyed goose, if this situation happens, and obviously it happens often enough because they make floppy nests, especially the first year, if an egg slides out, what do? They do exactly that action. They crane their neck and they bring the eggs in and then they shove it underneath their ovary. I'm trying to make sure, I can't remember, I don't want to show you the secret video. All right, I know, don't forget, stop everybody, this is a drawing, this is not real life. But they will bring the egg. Now, the goose, I'm going to show you a video in a little bit, but the goose does not get its butt off the eggs because, again, it's too cold. Let me see, what is this one? No? Okay. All right, everybody got it, right? So, her question, evil one, what happens if the egg is out here? So the question is, what happens if egg is rolls far away from nest? Far away from nest. What happens? Tell me what happens. Anybody want to guess? What are you gonna say? You said something. You with the black shirt, tapping your mouth like this. What do you think is gonna? Yeah, you. What do you think is gonna happen?
I was gonna say to leave it.
Ah, evil mother. First of all, can a non-circular egg roll far away from the nest in the bush? What's the answer? Unlikely. Right? Second, will the female ever go and get it? No. Evolutionarily, you notice that they are not nesting in your living room carpet. They're not nesting in your perfectly mowed lawn. They're out in the woods, all right? How often do you go out in the woods, you find some level surface where an oblong egg will roll. No. In fact, they did experiments. Tim Bergen did an experiment. Guess how far the egg has to, the furthest the egg has to be before the female goes, that's not mine. You know what it is? I'll tell you what it is. I can never find my stuff. No. Wait. Ah. It is, I did lose the number. Ah. Tim Bergen. He put the egg in various systems because he's a true behavioral biologist. He doesn't care about the survival of the egg. He's doing it for science, right? So he put the egg at various distance away from the nest. I'm going to draw the nest again, guys. He put them at various distance. He found, oh my God, I lost it. He found they will only retrieve the egg less than 0.5 meters, which comes out to about less than 1.6 feet. All right? Now, under normal evolutionary condition, the gray-eyed goose, let's say they evolved 300 million years ago. Will there be a situation where the egg rolls 10 feet from the nest? Is it their egg? Are they going to get up? Roll it back. Is it reproductively successful for them to get up from the other 3 that is there to go walk 5 feet, 4 feet, 6 feet, 10 feet to bring back that egg? No, right? In under all kinds of natural selection behavior and selection after selection after selection, eggs do not roll more than half a meter away, right? They are not nesting on a cliff. They're not nesting on a carpet here where the egg will roll, right? So they have a very specific strategy, the optimum trait value. Do not get up and get out of the nest to go pick up that egg over there, all right? They are only gonna go that far, all right? This is all innate behavior. Nobody teaches them that. As soon as the first time they make a nest, this is what they do. Everybody got it? All right? Second thing, so Tim Bergen wanted to know, you know, in terms of consummate, the first time you perform, okay, they do it perfectly. Now, what do you think Tim Bergen did, which was so typical of a good behavioral scientist, right? What do you think he did? He let the gray lag goose start the behavior, and then, you know what he did? He took the egg out in the middle of the behavior. So as the bird was going like this, he took the egg out. He removed it. What did the bird do? Yes. He attacked him. Hello. This is 400 million years ago. In 1954, there's an old German guy who's going to remove your egg. Attack him. What does the gray lag goose do?
Finish the behavior.
Finish the behavior. Is there a what-if situation in evolution? Like, what if I fail this course? Who do I kill? What's going to happen, right? There's no what if. There's no, like, in case of this, in case of this, in case of this, in case of this, change your behavior. Right? Watch it. See, the goose doesn't really get up that much. He rolls it in. Why does the goose not change his behavior? Because it's an innate programmed behavior, right? Does it ever have to consider that some scientist is going to remove the egg in the middle? Under any natural circumstances, is a fox going to come up and go and steal the egg? No. Why do I need to program just in case? What if? Right? These are very, very tightly inherited after many, many, many evolutionary years of very specific innate behavior that has high fitness and reproductive success. All right? It is so important that you don't get up that far, you roll that damn egg back in, right? Now, can it be double the distance? Is it going to work? I'm not going to do it because I'm sacrificing 3 other eggs that are in the nest, right? Everybody understand? So what happens is that if the egg is removed in middle of the sequence of egg retrieval, the gray lag goose will continue the behavior. All right? Because it is a fixed action pattern. The fixed action pattern is I visually see an egg outside the nest. I crane my neck and beak, and I roll it, and I shove it underneath my butt with all the other eggs. That is the fixed action pattern. Under no circumstances is it going to change, or is it going to be altered, or is it going to stop. Because it is very, very important for my fitness and reproductive success. I don't care if some guy took an egg in the middle, all right, or some snake comes along, because then there's a big issue, right? Once I start that behavior, I'm gonna stop. It's like back to those babies. If I took the baby and I went like this, and it went like this, and go, oh, ha, ha, you tricked me. No, they don't do that. It is evolutionary important that I hold on to a branch because I'm falling from a tree, all right? Everybody understand? So all of these things are called innate behavior. So Conrad, everybody understand what's going on, right? I'm going to show you something else. So they also came up with something called a super normal stimulus. Again, keep in mind that these birds or the lizard, or I'm going to do some insects, other ones later, they have had hundreds of millions of years of evolutionary culling, very specific behavior that allows survival to 2024, all right? They don't consider what if, what happened, like this, right? So what happens is that you have a cue. So the stimulus in this case, or the cue, is the egg outside the nest. Everybody got this, right? That's the visual stimulus, all right? So what Tim Bergen did, and Loran said, what happens if I put another object outside of the nest? What happens if I put a pool ball? Everybody play pool? No? And nobody plays pool? Yes? Of course you did, though. Are you a good hustler? In grad school, that's all we did. We drink a lot of beer and go play pool. I was terrible, because you know what? I'm bad in math, so physics, angle, like, I don't know what the hell's going on. They would put a pool cue ball. They would put a block. They would put a big ball. They would put all this just outside the nest, within the whole 0.5 meters. Yes?
What, does it say full?
Pool cue ball. You know what a pool ball is?
Yeah, I know.
Not balls that are in swimming pools. Okay. What do you think the gray-line goose did in all these cases? So, yes, make a guess, so we can all laugh at you. Huh?
They like run through the years.
They did. You're gonna say, well, how stupid can you be? But did they inherit, waste all their time to have a gene to go, that does not look like my egg, I'm not gonna bring it in. Is it worth it for them to make a gene to do that? No. They brought everything in that was within that zone of 0.5 meters, because it is worth it, right? Just in case it is their egg, right? You don't have to, that's why the optimum trait of these values of these genes is that you don't have to do the what ifs, all right? So they will do everything within that zone. Very specific. They have a zone because you don't want to get up, right? Oh my God, I forgot to make noise. This is a nice noise one. Is that its egg? That's a pool cue ball, okay, everybody? Aren't they a big bird?
An egg needn't be white or even egg-shaped.
Oh, so cute! So stupid, right? Ugh, a little dangerous. That's not the kind of scientist I would be.
In her eyes, even a wooden cube can pass for an egg.
Right? Do they need to know? All they need to do is the approximate cues. I see something outside the nest, I'm gonna bring it in. They will try to do anything, right? Is it an evolutionarily good strategy? What does everybody think? Yes. 99.99999% of the time, unless there's a scientist involved, it's going to be your egg, right? There's no thinking, well, someday someone's going to put a little Russian doll there and I'm going to bring it in. No, I'm not, right? So these are these large objects. These super large, crazy objects. They call them a supernormal stimulus because they still bring them into the nest, all right? Now, obviously, none of this happens in nature. This is all experimentation. What it's just showing is that there is a very precise proximate cue. I see something around my nest. That's not normal. That's not nest and grass material. I'm going to bring it in because it could be my egg. If it's not my egg, I have a light bulb. Maybe he's going to be smarter than the other eggs. Who knows, right? But the point is that it's around my nest. I'm going to bring it in. That's the innate behavior, and that's the FAP for this particular animal, the gray-lag goose egg retrieval behavior. Everybody got it? All right. So what Lorenz did, Conrad Lorenz, he did something similar. He looked at, he and Tim Bergen looked at, let me see what it was, herring gulls. You want me to draw a herring gull?
Sure.
Are you laughing at me? You know what? All my birds look distinctly different in different species, all right? The herring gull has a red dot on its beak. There are two FAPs here, okay? So the two FAPs are this. One, newborn, freshly hatched herring gull chicks. What they do is they peck on the red dot. Of parent. Why do they peck on the red dot on the parents? Freshly hatched from their egg, all right? Why do they peck on the red dot of the parents? No, not you two. Anybody? Oh, not you. Anybody else? Anybody want to guess? No, not you two. Somebody else in the back. Show me that you're even listening, that you're not buying something on Amazon. Yes, tell me. Exactly. The FAP for the chick, as soon as they hatch, is they look up and they see that red dot and they peck at it. They peck, 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 peck. What is the FAP for the mother or the parent? When chick pecks on red dot, Peter Piper, no, the adult regurgitates food into the chick's mouth. Regurgitates. Don't forget, herring gulls cannot use fork and knife and use the bottles, okay? All right? Are both of these FAP very important? You shook your head, they're not important? You went like this.
No, they're important.
Oh, they're important, okay. Is it important for the chick? Because the chick gets hatched, what does it need right away? Food, right? Doesn't need bread, doesn't need milk or whatever. It needs food, right? So it needs to tell the female, or not, sorry, it needs to tell the parent, because it could be male, it needs to tell the parent, I'm hungry, feed me. What is the FAP of the parent? If you peck on this dot, I'm going to, right? Are they both essential behaviors? Are they innate? In the egg, on the inside of the egg, does it say, peck on red dot when you get out? Does it say that? It says that it does. It says inside. I've seen the chick dog. So what Timbergen and Lorenz did was they said, okay, we know this behavior, so let's experiment with what will stimulate the chick, all right? So what they did was they made all kinds of models of the bird heads. So in some, oh my God, let me see. I'm gonna draw it just to stick you guys something, okay? So this is a model. It's not a real thing. So what they wanted to do is they wanted to test the FAP. They wanted to test what is stimulating the chick. All right. If I have a fake head of a bird with a red dot and I put it in front of the chick, will it peck on the red dot? What's the answer?
Yes.
Okay. Will it pick on a stick with a red line? What's the answer? Who votes yes? Who votes no? You're gonna die. Again, is there a what if? Is there enough of a stimulus of a red something that I'm gonna pick, right? You are gonna be like, excuse me, I would like mine presented nicely, regurgitated into a little bowl, right? So this is what they did, and they showed for the FAP and the whole genetic innate version that anything that resembles even vaguely something with a red something, not even a dot, the chick is going to peck at it because it is vital for its continual life to get fed, right? Is it vital for it to decide, oh, I think it's a steak. I'm not going to eat it, right? So there are many, many, many of these innate behaviors. Did I not draw a good herringbone? Yes, the neck wasn't that long, and there is a red dot, and there is a little hook on their beaks, right? So even with babies, right? If you take a little baby, okay, I've done lots of these experiments with my own babies, they're all strong, okay? And you're looking at them and you just brush their thing, they turn this way. Right? These are very, very, very important innate behavior. You cannot be taught this because you need food to survive, all right? So these chicks are also exactly the same. You can see that one is getting regurgitated food. They did everything. They did a natural head, they did a standard male, they just the beak alone and the stick alone, and look at their pecking rate. All of them stimulated it. Because the bird is not going to spend gene time thinking, is that a stick or is that really mommy's head, right? You don't. It is so important. They come out saying, encoded in them, peck, red, peck, 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 peck. I don't care what it is. Well, this is the one example where this bird is going like, this is a Arnold Schwarzenegger egg. I better get it back in my nest, right? All right. Yes. Of course there's a question. Yes.
If like the stick was maybe like a light orange, would it still work?
No, it has to have some kind of redness in it. If it was a black stick, it won't, because you need the stimulus of.
So if the chick hatches in, and like, okay, they have an adult bird, and the bird's not a parent, and a chick hatches near that bird, they put the egg in that bird's nest, right? And then the chick pecks that adult bird.
But does the adult bird have a red dot? If you
Yeah,
just
so,
said it's,
yeah, like if they have the adult, it's like the same species.
Okay.
They have a red dot, and they peck that adult bird
often are you going into somebody else's home and going, feed me, right? So I have to tell you, you know what? Depends on the age and the thing, because on average, parent animals know their offspring, right? On average. You don't go to the hospital and I see my baby, and then on the day that I leave, they give me a blonde baby. I'm going like, this is mine, but I'll take it anyway, right? So this happens a lot with farms when animals, like a cow or sheep dies. So if a mother cow dies and there's a calf, who is going to feed that calf? Because there's a connection in the smell of this is mine, this is my offspring, this is my calf, and the calf said this is my mother, right? But sometimes on a farm, it's the calf that dies and the mother's alive, right? So now you have a mother with no calf, you have a calf with no mother. How are you going to get that calf to be fed on this mother? How is that mother going to allow this strange calf to go feed it? Because now you've lost the calf. You've lost two calves if that calf doesn't get fed. What do they do? You'll never guess. It's a horror. No, it's not. It's a horror. They take the dead calf, they cut off the skin, they take the skin and they put it onto the other calf, and then the mother goes, oh, I remember you, and then slowly they take off that skin, right? Is it better to lose two calves or one calf? Right? So, yes, there's a special period, and you guys happened to mention it, and we're doing it now. You guys took so long that I haven't finished the lecture. You guys are horrible people. I am not going to ask any more questions from now on. All right? So let's do Lorenz, so that you guys can go away after this. He did imprinting, which is what some of you guys are thinking about, imprinting. Imprinting is a phase-sensitive learning that is restricted to a small time frame during development. Sometimes they call this the critical period. So, right after birth, depending on the species, there is a certain time of critical period. So, this length of time varies with the species. In some, it could be 2 minutes. In some, it's an hour and a half, but it's not very long. This is the time where the mother, the parent animal says, these are my offspring. It is also critical for the offspring to say, this is my parent. So it's a very narrow window. Sometimes, people say when you have cats and dogs and they're out in the wild, and then you grab one and you take it home, and it's like confused, like where's mommy, who's mommy, whatever it is, right? So there is a little critical time period. And what Lorenz did was he calculated what that time sensitive in a number of species. And one of them he did was the gray-lag goose. You guys have heard about this critical time period, right? All of this was invented and discovered by these three guys, all right? Before that, the word innate, what does it mean? Intrinsic, what does it mean? Fixed action pattern, what does it mean, all right? So he used the gray-lag goose. He wanted to know. So he had two populations. He had a mother goose. Oh, mother goose. He had another mother goose. This, he allowed all the eggs raised by the goose. In this one, he took the eggs and they were hatched by Lorenz. So he did lots and lots and lots of these all kinds of experiments, right? So he rotated the eggs and everything, and when the eggs hatched, different times he would expose himself. I know you're saying, What's he doing? Does he know? But he was the one that would feed the thing. So he discovered the critical period for this particular species and other birds. So when he raised them in that little window of time, right? So he fed them and he raised them. So they only were exposed to him, only him alone. I don't know if you remember, if you saw that picture of the three of them, he had all these little chickies follow behind him. So he every time he walked anywhere, these little chickies followed him. Why? Because if mommy goose was walking, what do the chicks do? They follow. Have you seen in the spring when the little ducks have little babies, right? When they're swimming, who's following them? Not ugly men, but all of its little babies, right? This is the critical window. You're my parent. I am your offspring. Let's all go together, right? So when they were about, 8 weeks old, doesn't matter the weeks, they were weeks old. He took some of these chicks, and he took some of these chicks, and he put them into a box and covered a lid over them. All right. So I should have probably put them. Okay, they put them in the box. He didn't even have to tag them. He just took a whole bunch of chicks and a whole bunch of chicks and he put them in the box. He stood. The mother goose was there, and Lorenz was there. So here's the mother goose. Oh, let me draw it the other way. Ooh, can I draw it the other way? There we go. Oh, look at Lorenz. I did it. He's smiling. He has no hair. All right. He put them. He stood as far away from the mother goose. Somebody opened up the box, the lid of the box, and let the chicks go. Where did these chicks go? Who did they looked? Where did they go? Where did these chicks go? Exactly, right? And then he did it at different times where he exposed himself a little bit later, a little bit later, and a little bit later. You don't need to know the time because that's not relevant. It's that every single species has a very critical window of time. Could be minutes, could be hours, could be days, right? But then after that, you are my parent. Doesn't matter. Or I'm not coming to you. So he figured out that there was a critical window that if you expose yourself after that, the chick goes, what's wrong with you? This is my mother, all right? So this is what he did. To the end of their lives, they thought Lorenz was mommy and daddy. Followed them all the time, right? Doesn't like chicks. So have you seen pictures where animals fly with other animals or fly with people on drones and airplanes? And I've seen a picture where this guy happened to save a little bird, and he just saved it, and he thought it was going to fly away, but the bird did. Every time he rode in a car, the bird flew right there. Because that's their mommy. So in order to create something like this, that individual in that little plane thing had to raise all these birds so that they would fly with him. Now, in fact, one of them, there's a study now, and I think it was in Africa. They're having issue with the migration pattern of these birds. Their normal migration pattern goes to areas where there's no more food. So they're trying to change their migration pattern by having them raise it, and then they fly, and they say, come this way, and then there are birds, so that they learn a different route, and they can tell their offspring this is the route. Got it? Let's quit now, so I can drink. I'm done. I'm done. We didn't finish, but I'm done.
Is that it? That's the end.